Pesticide drift is a major environmental concern in both the agricultural and turf care industries today. In addition to its potential environmental impact, drift contributes to negative public perception of spraying, spotty pest control, waste of chemicals, and possible off-target damage to nearby vegetation. Adverse environmental conditions and improper spraying practices and equipment are factors that contribute to spray drift. The key to avoiding spray drift is understanding these contributing factors and taking the appropriate action. The American Society of Agricultural Engineers, ASAE, defines spray drift as the movement of chemicals outside the intended target by air mass transportation or diffusion. There are two types of spray drift: vapor drift and particle drift. Vapor drift occurs when chemicals evaporate into the air, which then moves the vaporized chemicals wherever the air moves. This is similar to the movement of smoke when leaves are burned and the smoke sometimes drifts to undesirable areas. Vapor drift is usually associated with pesticide formulations that are highly volatile. The ester formulation of 2,4-D is an example of a highly volatile chemical. This is particularly true when the temperature is above 85 degrees. Know the characteristics of the chemicals you are applying and follow all label recommendations. Particle drift occurs when the wind scatters spray droplets off the application site to neighboring areas. This action is similar to leaves blowing from one yard to the next. Just like the scattered leaves, pesticide spray particles move with the wind. Unlike vapor drift, an applicator can control particle drift by following these important guidelines. Read and follow directions on the pesticide label. Check to ensure environmental conditions prior to and during spraying. Select the right nozzle for a particular application. Operate the boom as low as practical. To help ensure safe, accurate pesticide usage, it's important to read the label each time you use a product, regardless of how often you've used it before. Industry surveys indicate that approximately 67% of drift cases involve off-label uses, such as trying to spray with the wrong nozzle type. Most people don't realize that pesticides can drift up to a half a mile or 0.8 kilometers under the right weather conditions. Checking environmental factors prior to spraying and periodically during the application will help control and reduce drift dramatically. Environmental factors affecting drift are wind direction, wind velocity, relative humidity, and air temperature. Wind directly contributes to drift potential. Consider the direction the wind is blowing. Leave at least a 200 to 300 foot or 60 to 90 meter buffer zone if the wind is blowing towards nearby susceptible vegetation or sensitive areas. If a buffer zone isn't practical, spray these areas when there is no wind and adjust the sprayer for maximum droplet size. Wind speeds of 4 to 5 miles per hour or 6 to 8 kilometers per hour are manageable. But don't consider spraying if winds are in excess of 7 to 8 miles per hour or 11 to 13 kilometers per hour. Spray early in the morning and late in the afternoon when winds often die down. Use a handheld wind meter for a quick check while in the field. Relative humidity and air temperature also contribute to drift. Low relative humidity and high air temperatures accelerate the evaporation of droplets. This decreases droplet size and makes them easily displaced by wind. Spraying early in the morning or late afternoon when temperatures are normally cooler and relative humidity higher can significantly reduce drift due to high air temperatures. Avoid spraying under conditions of low relative humidity. If relative humidity is 50% or less, use caution when spraying. Minimizing fine spray droplets is perhaps the most important thing you can do to reduce drift. Larger droplets make it less likely that a pesticide will move off target because they reach the target faster than smaller droplets. As a result, larger droplets are less likely to be displaced by wind movement. Micron is the term used to indicate the measurement of spray droplets. Generally, most droplets from a conventional nozzle will fall between 200 and 600 microns, depending on the spray pressure. Fine droplets of less than 100 microns, or about the diameter of a human hair, drift easily. For best drift control, aim for spray patterns with as many as 300 to 600 micron diameter droplets as possible. Some applicators have shied away from spraying with large droplets because of possible reduction in coverage. However, coverage can always be enhanced by increasing the application volume. Unlike environmental conditions, droplet size can be determined and controlled by the applicator through the correct use of spray equipment. Droplet size is affected by spray pressure, spray angle, nozzle type, and orifice size. Keep in mind that to effectively reduce drift, larger droplets are required. Because nozzles are designed to operate within a specific pressure range, simply decreasing the pressure outside the operating range to produce larger droplets may result in a poor spray pattern. Poor coverage and distribution in the swath may also result. Know and operate at the lowest recommended pressure for the nozzle type you have chosen, but be careful not to spray with the pressure too low. Spray angle is another consideration when trying to reduce drift, especially with flat spray nozzles. Wide-angle flat spray nozzles produce thin sheets of spray solution with small droplets, whereas narrower-angle flat spray nozzles produce a more concentrated spray with larger droplets. Due to the production of larger droplets, a flat spray nozzle with a narrower spray angle can provide better drift control. However, when boom height is taken into account, wide-angle nozzles have an advantage. At lower boom heights, wide-angle nozzles provide the same ground coverage while reducing wind drift because the droplets are closer to the target. When narrow-angle nozzles are operated too close to the target, spray coverage uniformity can be significantly reduced. To minimize drift, spray height should always be kept at the lowest recommended setting for the spray angle of the tip you are using. Remember, though, that as you lower the nozzles, overlap is decreased. If boom height is lowered below the manufacturer's minimum spray height recommendations, a striping effect, as shown in the slide, may result. Also, because of the low height, the sprayer should have a spray boom capable of maintaining a level position during spraying. Because boom height is so critical, boomless sprayers are not recommended when drift is a concern. It is much more difficult to control drift with boomless sprayers because the spray pattern goes in many directions, not just towards the ground. There are specific nozzles which are designed for better drift control. Understanding these nozzles and their characteristics is key in selecting the one that's right for your particular spraying needs. The XR TeeJet is an extended range flat spray tip that allows the droplet size to be controlled by varying the spray pressure while maintaining the proper spray angle. This tip creates a tapered flat spray pattern that overlaps with adjacent sprays while maintaining its pattern at low operating pressures between 15 to 25 psi or 1 to 1.5 bar, ensuring uniform coverage along the boom. The DG TeeJet or drift guard tip is a new variation of the flat spray tip that utilizes a pre-orifice which produces larger droplets and reduces the small drift-prone droplets, minimizing off-target spray contamination while spraying at pressures of 30 to 60 psi or 2 to 4 bar. The full jet nozzle produces a wide-angle full cone spray that offers excellent drift control when operated at pressures from 15 to 25 psi or 1 to 1.5 bar. This nozzle provides very large droplets, many more than 1,000 microns, at lower pressures, which maximizes drift control. The wide angle and a 45-degree mounting angle permit low spray height settings. The new Turbo Flood Jet wide-angle flat spray tip is ideal for drift reduction because it produces large droplets. A patented atomization chamber and pre-orifice combine to produce large droplets and uniform coverage. The wide angle allows low spray heights and is operated at pressures between 10 to 25 psi and 0.7 to 1.7 bar for maximum drift control. In addition to nozzle type, the size or capacity of the orifice can influence the droplet size. The larger the orifice, the larger the droplet. Remember, when changing to a larger capacity nozzle, applicators should calibrate and mix accordingly. A few minutes spent choosing nozzles can help prevent possible spray drift or poor pest control, but controlling drift doesn't stop at selecting the correct nozzle. The sprayer operator has other options to ensure drift is kept to a minimum. Shielded booms have been gaining popularity as environmental concern has heightened. These protect the spray pattern from the wind and allow the spray droplets to reach the target with minimal disruption. Shields are available for individual nozzles or entire booms. Drift control additives or thickening agents can reduce downwind drift by 50 to 80%. There are a number of products available as additives, and it's important to follow label directions carefully. Incorrect concentrations or mixing procedures can lead to poor distribution patterns and low flow rates. The complete elimination of drift is not practical. However, minimizing the potential for drift is well within the applicator's grasp. Many things can be incorporated into the spraying operation. To avoid drift due to environmental conditions, avoid spraying when wind direction is unfavorable, winds are strong, relative humidity is low, and when air temperatures are high. To minimize drift when spraying, use low spray pressures, lower boom heights, select the correct nozzle type, and use larger orifice sizes. Understanding the contributing factors of spray drift and taking the appropriate action to avoid it is important to ensure a safe and healthy environment. By using the techniques given in this presentation for careful and precise application of pesticides, you can help provide a safe environment for everyone.